Hi there, I'm Amelia. I'm a PhD student researching mathematical physics at the Mathematical Sciences Institute at the Australian National University. When you throw a ball to your dog, have you ever noticed the trace of the ball? Have you ever wondered why the trace of the ball is always of a certain kind of shape? And do you want to reproduce the shape on paper? Today, I will introduce 3 interesting yet simple activities about string art, paper folding, and gravity, which would give you some ideas about that mysterious shape. In the first part, let's start by choosing any 2 points on the grid that are at least 5 centimeters apart. Just make sure one is not directly above the other. And then rule a line through your points, extending it a bit on both sides. Okay, next, from one of your chosen points, move along the grid 1 unit down and 1 unit to the right. And move the other point 1 unit up and 1 unit to the right. And now rule a line through your new 2 points, as before. We need to repeat this step as many times as we can, and then we go back to the original pair of points and move them up left and down left, respectively. So now we have drawn lots of lines. So as we add more and more lines, a shape starts to emerge. Okay, now compare your result to your classmates who chose different pairs of points. Are their curves steeper or flatter than yours? If you are tired of drawing dots and lines, but still willing to experiment more on this activity, there's a website for you. And here it is. You can find the address of the website in your instruction. Okay, now let's try a bit. You can add the lines using this slider. And you can change the chosen point anytime just by dragging the points. And we can also view the curve simply by clicking the Show or Hide curve. Let's move to part 2. First, put a dot somewhere near the middle of the page. It doesn't have to be very exact. Actually, it would be better to keep your choice fairly random. Next, choose 1 point on the bottom edge of the paper and fold the paper up so that it exactly meets the dots. Make a sharp crease in the paper. Now unfold the paper and repeat the previous step with another point on the same edge. We need to repeat this procedure as many times as possible. As we make more and more folds, a familiar shape starts to emerge. Now compare your results to your classmates as in part 1. If you'd like to explore more, but don't want to waste more pieces of paper, there's again an eco-friendly solution for you. Here is another website for you, which you can also find in the instruction. With this simulator, we can watch the animation of folding the paper using the slider. And if you tick the box of Show Single Fold Line, the fold line will be held even after unfolding. And you can change the fixed dot and the contact point just by dragging them. And have all the fold lines in hand is as easy as ticking the box of Show All Fold Lines. And we can view the curve by clicking Show Curve, just as before. Up to now, we've been creating a curve from dozens of lines. In the last part, we will be able to find the curve directly. In this part, first, tape the butcher's paper to the desk and tilt the desk on a slight angle. Then let's make a wrap by folding a strip of cardboard lengthways and make 2 more folds at one end to form the support. Set the wrap at the bottom of paper and aim it towards the back of the desk with a slight angle. Okay. Now roll the marble down the wrap and make a note of the path. Usually it takes a bit effort to find the right length, height, position, and the angle of the wrap to get a desired shape. And maybe you also need to try different surfaces to see how different it behaves. Once you note the desired curve, dip the ball in a little paint and roll it again to draw the curve on the butcher's paper. We've shown 3 different activities that lead to the same kind of shape. This kind of shape is called a parabola. The first 2 activities reflect some geometric properties of the parabola. This is the way parabolas were studied by the ancient Greek more than 2,000 years ago. Later, mathematicians invented more mathematical tools such as coordinate systems, algebra, and calculus to help study parabolas and other curves. Famous mathematicians such as Galileo and Newton were able to use these tools to reveal the connection between parabola and gravity in the 17th century. But even when you understand the theory, it's still surprising that the same shape turns up in so many different ways. And we haven't even discussed satellite dishes and headlight reflectors. Why don't you try to find out more about this fascinating shape? Enjoy science in your daily life.